Continuing with our lesson over quadratics and parabolas, we're just going to be emphasizing today again our vertex and our line of symmetry. So recall that your vertex is always the bottom point on the graph or the top point on the graph. It's wherever the graph curves, where the elbow of the graph is. So down here, in this case, it's the bottom, which is a minimum value. The vertex formula is the formula negative b over 2a, which comes from our standard form of a parabola, or standard form of a quadratic, which is y equals ax squared plus bx plus c. So it's important for you to remember that a is the number in front of x squared, and that's what's going to go in our denominator, and b is the number that is in front of x, which is going to go in our numerator. Remember this negative sign that's here just means it's the opposite of whatever b is. And then don't be confused by this weird f of negative b over 2a notation here. All this means is that we need to plug this number back into the equation for x, which we're going to practice that. It's also important to remember our line of symmetry is the line that goes through the middle that splits the graph in half, so that this half on the left is identical to the half on the right. And its formula is also negative b over 2a, so the same formula that was over here. And for all of our parabolas, remember that our domain is always all real numbers. So it's important also to recall that depending on which direction the parabola opens determines if the vertex is a maximum or if the vertex is a minimum. So if a parabola opens down, which means that there's a negative ax squared, then the parabola is going to have a maximum value. If the parabola opens up, which means there's a positive a in front of x squared, then it's going to have a minimum value. So I have a graph here that we've got to determine the vertex, the axis of symmetry, and the y-intercept. So we're first going to start with the vertex. Well, the vertex is going to be the lowest point on my graph, or the highest point, wherever the graph curves, which in this case is right here. So this point is my vertex, and this ordered pair is the ordered pair starting at the origin. This would be positive 1, 2, 3. So it's going to be 3, and then going down, that's 1, 2, 3, and negative 4. So this is the ordered pair 3, negative 4. So my axis of symmetry is going to be a vertical line that goes through the vertex. It's very important to remember that it always goes through the vertex, and its equation is always going to be x equals, and it's whatever value the line of symmetry touches the x-axis at, which in this case it touches the x-axis right here at positive 3. So its equation is x equals 3. And lastly, the graph asks us for our y-intercept. Remember, a y-intercept is where the graph crosses the y-axis. So here's my y-axis. Here's the graph. They intersect at this point right here. For all y-intercepts, remember the first number is 0. The last number is going to be the y value. And in this case, so again, these are going by 2's. So this is 1, 2, 3, 4, and 5 right here. So it's going to be the ordered pair 0, 5. Then I have an equation, y equals negative 2x squared plus 12x minus 5. So first of all, if we know it's negative, just to kind of give a rough sketch of the graph, we know if it's negative, it's going to open down. So that tells us our vertex is going to be up here at the top, which is going to make it a maximum. It's important to remember that it is going to be a maximum. So in order to find the vertex and the axis of symmetry, I have to use my formula, which is the formula negative b over 2a. Remember, a is the number in front of x squared, b is the number in front of x, c is the number by itself. So when I go to plug those in, for b, let's do b first because that's on top. For b, I'm going to plug in positive 12. So I'm going to rewrite this formula as negative 12, because remember this negative sign that's here means I'm going to do the opposite. So negative b means the opposite of b. b was positive 12, so in the formula it's negative 12. Divided by 2, this 2 is always in the formula. This 2 right here is always in the formula. And then for a, I'm going to plug in negative 2. So instead of a, I'm going to plug in negative 2. Well, negative 12 is still on top. 2 times negative 2 is negative 4. And negative 12 divided by negative 4 is positive 3. So we have found out two things. The first thing we found out is we now have the x value of our vertex. We now have the x value of our vertex. The second thing we have is we have our equation for our line of symmetry. So these two numbers will always be the same. They will always be the same. Then to find the other half of my vertex, I need to plug this number, this 3, back into this equation for x. So I'm going to rewrite the equation. So I have negative 2, I'm going to leave blanks for x, plus 12, leave a blank for x, minus 5. And instead of x, I'm going to plug in positive 3. And then I'm going to work this out. And I can put it on the calculator at one time, and it's going to give me positive 13. So this is the second half of my vertex. So this 13 here is the second half of my vertex. The other thing that 13 is that 13 tells me a couple things. It tells me the maximum value. It tells me the maximum value is 13. It also tells me about my range. So because this opens down, we know our range is going to be y's that are less than or equal to, and it's actually going to be y's that are less than or equal to positive 13. So I just keep using those same numbers over and over again. Just depends on what the question's asking for. So one more. We have 3x squared plus 18x minus 1. We've got to determine the maximum or minimum of the graph. Well, it's a positive x squared, so since it's a positive x squared, we know the graph is going to open up. And again, we know that because 3 is positive here. So if it's opening up, then that tells us that our graph is going to have a minimum value. It's going to have a minimum. And to find that minimum value, the first thing we have to use is we have to use our formula for our vertex, negative b over 2a. Again, we're going to figure out what a, b, and c are. So if I label these above the equation, it's ax squared, so a is 3, plus bx, so b is negative 18, plus c, so c is negative 1. So that tells me that my b value is going to be positive 18. That also tells me that my a value is going to be positive 3. So I'm going to rewrite the equation with those numbers in there. So it's going to be negative 18 over 2 times 3. That'll be negative 18 over 6, which is going to be negative 3. So now I'm going to take this negative 3, and I am going to plug it in for all of my x's. So I'm going to rewrite the problem, and instead of x, I'm going to leave a blank space for right now. So 3 parentheses squared plus 18 parentheses minus 1. And in place of these parentheses, I am going to put this negative 3 because that's what I found out was the x value of my vertex, or my minimum value. So then I can plug all this in the calculator, and I'm going to get negative 28. So the maximum, or the minimum value, the minimum value of our graph is going to be negative 28. Recall that's going to tell me one other thing. That also is going to give me my range. So my range of my graph, because this parabola, remember, it opened down, as we see up here in this graph, because my parabola opened down, then I know my range is y's that are less than or equal to, and they're going to be less than or equal to negative 28, because that was the value that we got for our maximum.